Hello students, in the last class I explained about wavefront and Huygens principle, and today class I will explain the phenomena of light, what you have studied in ray optics, that is reflection and refraction. Here I will explain first refraction of plane waves by using Huygens principle or Huygens wave theory. Okay. So this is important for 3 marks. We are once again explaining the refraction, but here we are using the Huygens principle. For this, let us consider a refracting surface. This is the boundary surface which separates two medium. So let us consider this is denser medium and this is rarer medium. So here rarer medium refractive index, let us take N1, and denser medium refractive index, let us take N2. Plane wave or plane wavefront. How to represent the plane wavefront means, so in this way, this straight line is representing ray of light. Okay, so for this straight line, if you draw a perpendicular line like this, okay, so this is nothing but a plane wavefront. In the last class also I explained 3 types of wavefront, that is a spherical, plane and cylindrical. So how we have represent means, this is the plane wavefront means these are the ray of light. Similarly, this is the plane wavefront. Okay, AB is the plane wavefront, and if you draw a perpendicular line to this wavefront, this will represent ray of light. So the plane wavefront is incidenting on this refracting surface. Let us say this is a incident wave front. Okay, and if you draw, that means you can draw a normal line at the point of incidence, then this angle becomes angle of incidence I. And see the diagram carefully, this angle is I, so these two are perpendicular, then this angle becomes 90 minus I, then this dotted line and this surface, again the angle is 90 degree, isn't it? That means, so this angle becomes, this angle is 90 minus I means this angle becomes I. So from the diagram, observe carefully, you came to know that if this angle is I means this will also comes to the angle I. And here we have to recall the Huygens principle. What Huygens principle states means, every point on the wavefront is a secondary source or behaves as a fresh source, and from this source again the disturbance will travel, the wavelets will emit, and it will spreads in all the direction, moves with the same speed of the wave in the medium. So then from A point also the disturbance will travel, and from this point also the disturbance will travel. But you see carefully, already the disturbance has reached this refracting surface, but from B point the disturbance has to travel to reach the refracting surface. Let us take that refracting surface as x dash. Okay, and speed of the wave in the, or speed of the light in the medium, let us take it as v1. Then I will consider the disturbance will reach this refracting surface, or let us say the point C. It will take the time t. In t time, from this point B, the disturbance will reach us point C. Then how much distance it would travel? That means in t time the speed of wave is v1, means it has travelled v1 t distance. But what about A point here? Already it has reached the refracting surface, right? In the same time t, the disturbance has to travel in second medium. Okay, then the speed of light in the second medium is v2. So in the same time t, the disturbance will enters in the second medium. Then how much distance it will travel means v2t distance it will travel. That means here in t time the disturbance from B point to reach C point, it will travel v1t distance. In the same time it has already reached, next it has to enter into the other medium. In the same t time, how much distance it will travel means v2 distance it will travel. You know that how to get the position or in the shape of the new wavefront after time t. So after knowing this v2t distance, what we have to do? We have to take v2t as a radius, and we have to draw a sphere. Okay, like this we have to draw we have to take v2t distance as a radius, and we have to draw a sphere. I just represent an arc here. After drawing spheres, then what we have to do to get the new wavefront, that is position of wavefront later at time t, from this C point we have to draw a common tangent. Okay, so this is the common tangent drawn from C point. Then this will be the wavefront after time t. This is incident wavefront, means this is refracted wavefront. Then what we have to do here? We are here, this is the perpendicular line for this sphere. This represent a ray of light. Okay, this common tangent what we have drawn, that represents wavefront. So here also you can see at this point, this is the normal, and this angle is said to be I, and you know that when the light ray is traveling from rarer medium to denser medium, obviously it bends towards the normal, and then this angle is that means this angle becomes here also. So this is the normal line, right? So this angle is called what? This angle is called angle of refraction. Here also this angle is angle of refraction. So how we got here this angle is I. In the similar way, if you see carefully the diagram, you will get this angle is R. And this is what? Incident wavefront. And here this wavefront is what? Refracted wave front. Okay, and remember here it covers less distance in same time t. Why? Because it is denser medium. Here it will travel more distance, that is V1 t. Then how to explain or how to prove the refraction phenomena means, here you can see the triangles. Which are the triangles means, so this is the sphere we have drawn, right? Let us say this point is D. Always remember, for the ray of light, this is ray of light, this is a wavefront, means the angle is 90 degree. Here also the angle is 90 degree. Then you can see the triangles here. Which are the triangles means, in triangle ABC, in triangles ABC and ADC, okay, in these two triangle, if we apply sine function, that is if we find the ratio of sin I by sin R, so for this triangle, okay, for this triangle ABC, if I apply sin I means opposite by hypotenuse. Opposite is BC, hypotenuse is AC. And similarly sin R, for this angle is R, right? For this triangle ADC triangle, sin R is equals to, opposite is AD and hypotenuse is AC. That means AC by AD. Here this AC and AC will get cancel. You will get sin A by sin R is equals to BC by AD. Then what is BC? BC is equals to V1T. What is AD here? AD is equals to V2T. Then if I substitute the values of BC and AD, sin I by sin R is equals to, you will get V1T by V2T. Again here T will get cancel. Then sin I by sin R is equals to V1 by V2, and you know that that is the refractive index formula, n is equals to C by V. Because n is equals to C by V, you can write here sin I by sin R. Sin I by sin R is equals to, in the place of V1 you can write C by N1, in the place of V2 you can write C by N2, that will become N2 by C. Here C also will get cancelled. Finally what you got means sin I by sin R is equals to N2 by N1. That means you can able to write here N1 sin I is equals to N2 sin R. Okay, this is what we have studied as Snell's law, isn't it? That is the proof. So we have proved the refraction phenomena by using Huygens principle or Huygens wave theory. This is important for 3 marks. Okay. I hope you understood this derivation. So directly I derived here, but while writing in exams, you have the diagram you have to draw very neatly, and also along with considerations what I have explained. Those are all considerations only. You have to write considerations and then you have to derive that refraction phenomena. Okay. Then after understanding this refraction by using Huygens principle, now I will explain one more phenomena, that is reflection of plane wave by using Huygens wave theory. Reflection of plane waves by using Huygens wave theory. So consider a reflecting surface. Previously you have studied refraction, hence you have considered a refracting surface. Now consider a reflecting surface. On this reflecting surface, a plane wavefront. So this is what? A plane wavefront is incidenting. So just now explained how to draw a plane wavefront. These are ray of light. So let us take this point is A and this point is C. From this point you draw a perpendicular line. Okay, this is the perpendicular line. Then this point, let us take it as D. Then take it as B. Then this AB is called as incident. This AB is called as incident wavefront. Okay, these lines represent a ray of light. So an wavefront is a plane wavefront is incidenting on a reflecting surface. That reflecting surface name, let us give it as x dash. Then here what happens, you can draw a normal line here. Here also you can draw a normal line, and this is nothing but angle of incidence. And by seeing the diagram carefully, you came to know this angle is also equals to I, that is angle of incidence. Then from A point also the disturbance will travel, B point also the disturbance will travel, but the disturbance already reached this reflecting surface. But here from B point the disturbance has to reach the reflecting surface. So I will consider the speed of light in this medium is v. In previous case, that is there are two medium, hence one medium speed is v1, another medium speed is v2, like that we have considered. This is the reflection phenomena, right? The light will bounce back into the same medium, hence we will consider just speed of the medium, the speed of light in this medium is v, and I will consider that the disturbance will take t time to reach from B point to C point. Then how much distance it has to travel? It has to travel vt distance. Then from B to C point the light ray will travel vt distance. And next, in that same t time, what the disturbance will stay here? No, this will also travel, no, but it will not enter into the second medium. Why? Because this is reflection. It will bounce back into the same medium. So how much distance the disturbance from A point will travel means, again the speed is same. So it will also travel vt distance. Next, what you have to do, you have to consider A as a center, you have to take vt as a radius. Okay, so this is vt distance, means you have to take vt as a radius and you have to draw a sphere like this. You have to draw a sphere. Then next thing, what you have to do, you have to draw a common tangent from C point. So this is the common tangent from C point. And if you draw a perpendicular line, then this is a reflected ray, and observe carefully, this becomes the reflected wavefront. Okay, so let us give this point name as D. So AB is incident wavefront, and here this point is C, right? Then this CD is nothing but AB is incident wavefront and CD is reflected wavefront. So here this is incident light ray means, so angle of incidence is equals to angle of reflection. Like that you can draw a ray of light and you can observe now. So carefully, this is incident wavefront and this is reflected wavefront, and this angle is R, right? So this angle is R means, so observe the diagram, this angle also comes to R. So how you got this angle is I. Similarly, observe the diagram carefully, this angle also you will get R. Then here we have to prove this reflection phenomena, that is angle of incidence is equals to angle of reflection. For that, see the diagram carefully. Here you can observe two triangles. One triangle is ADC triangle and another triangle is ABC triangle. Okay, in two triangles this AC is common and these two angles also same, angle D equals angle B, and then this sides, AD distance is also VT and this BC distance is also VT. So you can say that the triangles ADC and the triangles ABC are common. Why? Because here AC is common and AC is common, and one more thing is AD distance is equals to, you can say that BC distance, both distance is equals to V into T. Hence triangle ADC and AB, triangles ADC and ABC are congruent. Hence we can say that angle BAC should be equal to angle DCA. That means here angle of incidence I should be equals to angle of incidence R. So we have proved that law of reflection, angle of incidence equals to angle of reflection by using Huygens wave theory. I hope you understood both refraction phenomena and reflection phenomena by using Huygens wave theory. And next concept, that is refraction. Just write as note. Okay. Refraction of plane waves. First, through the thin prism. Let us consider a thin prism and consider a plane wavefront. So this plane wavefront is passing through the prism. Then we have to predict what will be the shape of the wavefront after passing through the prism, after refraction through the prism. So this we can able to explain by Huygens principle. So see here, this is a wavefront. So initially here in upper side the thickness is less. So two different mediums are there now. This is air medium, this is glass medium. And you know that the speed of light in denser medium is less. So this portion will travel lesser thickness. as you come downside, this portion has to travel in denser medium, that is in more thickness. So obviously what happens means, you will see the wavefront after refraction like this. Why? Because this has to travel less distance in denser medium. Why? Because thickness is less, hence it will come out fast. But this portion has to travel in more thickness, hence here some time is delayed, okay, due to the more thickness. So finally you will observe the wavefront like this. It will tilt by some angle. And next one, suppose if you have lens, a thin lens, then an wavefront, a plane wavefront is incidenting on this lens, then what happens? Similarly, the same concept, this portion has to travel lesser thickness, but here this portion has to travel here more thickness. So this portion again it has to travel lesser thickness. Finally, what shape of wavefront you will observe means, you will observe not plane wavefront. Once after the plane wavefront passes through the lens, the wavefront shape becomes spherical. Okay, so here this portion has to travel more thickness, hence there is some delayed, and here has to travel less thickness, it will come fast from the lens surface. And if you draw a perpendicular line that indicates a ray of light, it converges to a point. That point is called principal focus. So this is what you will observe. A plane wavefront is passing through a lens. And similarly, if you consider a concave mirror, so in this concave mirror, let us consider a plane wavefront is incidenting. This is the plane wavefront. This plane wavefront is incidenting on the concave mirror after a reflection. So here what happens? Here in the wavefront there is some depression, right? Why? Because here the thickness is more. So here what happens here? So once the plane wavefront incident on the mirror means, definitely this will incident first. This portion will take some more time. Why? Because due to the curved surface. And after reflection you will observe again a spherical wavefront, a plane wavefront incidenting to a concave mirror, and after reflection the shape of the wavefront becomes spherical. Then if you draw a normal line, then if you draw a normal line, then this will appears to converge at some point. That point is principal focus. Just remember this concept. It will not ask in any PU exam, but in some competitive exams this concept is useful. In the next class I will explain Doppler effect in light. Then we will that means I will explain that is important concept, interference. Thank you.